Hey, what's up everybody, and welcome to this tutorial series on Jenkins. My name is Moss, and I'm an experienced DevOps engineer with 6+ years of experience in the DevOps industry. Now that you know who I am, let's go ahead and take a look at the roadmap of topics that we're going to cover in this series. We'll start off with the basics and then progressively get into more advanced topics related to Jenkins. And in our first topic, we're going to answer the question, what is Jenkins? After we have a high-level understanding of Jenkins, we'll then install and configure Jenkins on our local machine. Once we've done that, we'll then install and configure the Maven plugin. And after we install the Maven plugin, we'll then learn how to integrate Jenkins and GitHub. I'll then show you how to schedule Jenkins builds using build triggers. Once you learn how to schedule builds, I'll then walk you through the creation of a Jenkins job for a Maven project. I'll then walk you through the configuration of a Jenkins controller and Jenkins agent nodes to facilitate distributed builds. This will lead us to an introduction of Jenkins pipelines, and we'll create our very own pipeline in our Jenkins instance. And finally, we'll add automated cross-browser testing into our Jenkins pipeline using Lambda test. Now that you know what we're going to cover in this series, let's get started with the first topic. What is Jenkins? Jenkins is an open source automation server, and we use Jenkins to automate certain steps in the software development process. Jenkins helps software teams facilitate continuous integration and continuous deployment or delivery. In addition, Jenkins is a highly extensible tool. There are hundreds of plugins for Jenkins, and these plugins add functionality to Jenkins, or they enable Jenkins to integrate with other tools of the software development process. But why do we need Jenkins? What problem is Jenkins solving in the software development lifecycle? To understand this, let's take a look at a couple of key objectives for developers. The first objective is that developers who are working in parallel want to make sure that the features that they're developing integrate into the latest version of the codebase without errors. Without Jenkins, manual integration of changes happens infrequently. And because manual integration doesn't happen frequently, there's often a large backlog of changes pending to be merged. And this causes the manual integration process to be time-consuming, and we often refer to it as integration hell. The second objective is that developers also want to make sure that their changes are built and tested in a standardized environment. When a developer is testing a new feature locally on their machine configuration might not match the same configuration of another developer's machine. For instance, the developer's machines might not have the same version of the software framework that they're using to develop their product. And because of this, the new feature might work on one developer's machine, but not a different machine. Jenkins provides software teams a standard might not have the same environment, allowing them to avoid this issue. Now that we know why we need Jenkins, let's understand where Jenkins fits into the software development process. The software development lifecycle begins with the requirements definition or planning, followed by the design of the product. We then implement the product based on the design, and once we have an implementation, we then test that implementation to ensure that it meets the requirements that were first defined at the beginning of the lifecycle. Once the product is successfully tested, we deploy it to the customer and perform maintenance or operations on it. Jenkins fits into the testing and deployment steps of the software development lifecycle. And more specifically, Jenkins helps us automate the testing and deployment of our product. Now that we know where Jenkins fits into the software development process, let's take a look at the architecture of the software development workflow with Jenkins. This sequence diagram outlines the software development workflow, and it primarily focuses on the role of Jenkins in the software development workflow. To begin the sequence, the developer writes code, and when they feel like their code is ready to be reviewed and tested, they then check that code into the source code repository, and this might be a tool like GitLab or GitHub or Bitbucket. When the developer checks in their code to the repository, this should trigger a build in Jenkins. In this diagram, I show the communication going from the source code repository to Jenkins, but this isn't always the case. Sometimes Jenkins is configured to poll the source code repository for new changes, and anytime it detects new changes in a particular repository, that will also trigger a build. But it's important to note that it's always best, if possible, to push new data to Jenkins rather than having Jenkins consistently pull the source code repository, because that might put an unnecessary load on the source code repository system. Once a build is triggered in Jenkins, Jenkins will then pull the developer's code changes down to its local workspace, where it will build and test the code automatically using the latest version of the codebase. If the automated build and test steps complete successfully, Jenkins will automatically deploy those changes to the production environment. If the build and test steps fail, the automated deployment will not happen. Regardless of whether the build passes or fails, Jenkins will still publish results to the source code repository. It's important to note that Jenkins itself is not performing the build, test, and deployment operations. It's simply facilitating the automation of these steps. For instance, in the testing step, Jenkins may trigger JUnit test cases to run automatically. And although Jenkins may not deploy changes directly to the production environment itself, it may utilize a tool like Chef or Ansible in order to update the configuration of the production servers to use the latest version of the software. Now that we have a better understanding of Jenkins architecture, we can begin with our next topic, install and configuration of Jenkins. Hey, what's up everybody? My name is Moss and welcome back to our tutorial series on Jenkins. In this video, we're going to be covering how to install and configure Jenkins. There are multiple installation methods for installing Jenkins. You can run Jenkins from a web application resource file, also known as a WAR file. You can also run Jenkins as a Docker container from a Docker image. You can install Jenkins on Windows using a Windows executable file. You can also install it on Mac OS. And finally, you can install it on many Linux distributions such as Red Hat or Ubuntu. In this video, we're going to be running Jenkins from a WAR file. And the reason that we're going to be running Jenkins from a WAR file is because the WAR file is platform and operating system independent. Whether you're following this tutorial from a Mac or a Windows or a Linux machine, you'll be able to run Jenkins from a WAR file using the same steps that I'll be taking. The only requirement is that you have a supported version of the Java runtime environment installed on your machine. Jenkins supports Java versions 8 and 11. Java versions 9, 10, and 12 are not supported. Now that we've covered the necessary details, let's go ahead and get started with the installation. Okay, so the first thing that I want to do is just verify that I have Java installed on my machine. And to do that, I'm going to open up a terminal session. And in my terminal window, I'm going to type in java-version. And you can see in the output of this command that I have the Open JDK version 11 installed on my machine. So if you don't have Java installed on your machine, you'll want to make sure that you go ahead and install either version 8 or version 11 of either the JDK or the Java runtime environment before proceeding with the tutorial. So now that I've verified the version of Java that's installed on my machine, I'm going to open up my browser and I'm going to search for Jenkins. In the first link, jenkins.io, I'm going to select the download link. And in the download page, I'm going to scroll down to where I see the generic Java package, which is the WAR file. And I'm going to go ahead and download this package. And click Save File. And I'm going to open the containing folder. And I'm going to move this jenkins.war file into my home directory. If you would like to run Jenkins from a different directory, that's fine. I'm just going to put it in my home directory for my own convenience. Now that I have the WAR file in the home directory, I'm going to navigate back to my terminal window. And in my terminal window, I'm already inside of my home directory. So if I do an ls, I can see the jenkins.war file is in the directory. And all I need to do to start Jenkins is invoke Java, pass in the -jar option, and then the name of the WAR file. So we're going to say jenkins.war, and that will start the Jenkins server. And this command is blocking, so it's not going to return back to the command line as long as Jenkins is running. And Jenkins by default is going to be running unless we were to specify in the invocation to Java pass in parameters to the program. Jenkins will by default start running on localhost port 8080. So if we navigate to localhost port 8080, what we should see is the startup menu with Jenkins, and sure enough, we see the first the first startup page for Jenkins is to unlock Jenkins. So in order to proceed, we have to secure the initial admin password, which is provided to us in the output of the Java command when we start up the Jenkins server. So you'll notice here it says, please use the following password to proceed to installation. So all I need to do is just copy that password. And this password is also located inside of this directory. So .jenkins secrets initial admin password. So I have that copied. I'll select continue. And then on the next page, we can customize Jenkins to some extent using plugins. So as it says here, plugins extend Jenkins with additional features to support different needs. And it's best to install the suggested plugins. If we wanted to, we could select a subset of plugins ourselves, but in our case, we'll just select the suggested plugins. So Jenkins is now installing all of the most popular plugins that are available with Jenkins. And a couple that I'd like to point out here is the Pipeline plugin, which we will use in this tutorial series. The Git plugin, which will install Git on this Jenkins server and will allow Jenkins to communicate to source code management systems that are using Git. Okay, so now that the plugins have been installed, we can create our first admin user. And the first admin user that I'm going to create, the username is just going to be Moss. I'll type in a password here, and for the full name, I'll just continue with Moss, and then I'll enter an email address here. Okay, and then I'll click Save and Continue. Now, if we wanted to change our instance configuration and select a different Jenkins URL, we could do so here. I'm going to leave it as the default localhost 8080. And I'm going to select Save and Finish. And then I click Start Using Jenkins, and we should be brought to the Jenkins dashboard. So now we're at the Jenkins homepage, and I'd like to get you familiar with the Jenkins UI and introduce you to some key components of the Jenkins interface. So to facilitate automation tasks, Jenkins has what are known as jobs or Jenkins jobs. And anytime you need to perform a task using Jenkins, you need to create a Jenkins job. And there are various types of Jenkins jobs that you can create, and those jobs are listed under the new item page here. So let's go ahead and navigate to the new item page. So on this page, we can create a new item in Jenkins, and we can provide a name for that item. We can say test job here. And after we provide a name, we can select what kind of a job or what kind of an item this is. And the first option that we have is a freestyle project. And a freestyle project is really for simple software development workflows. It's for simple projects and code bases where you might not have a large number of steps to build and test your software. The next item is pipeline jobs, and pipeline jobs are good for more complex software development workflows that include build, test, and deployment steps, but also might include building multiple code bases rather than just a single code base or a single repository. And one of the benefits of the pipeline jobs is that we can store these complex steps as code, and we can write a file called a Jenkins file, and that Jenkins file will outline all of these steps that we need to take in our software development workflow in order to build, test, and deploy our software product. And later on in this tutorial series, we'll have a dedicated video covering pipelines and how to create a pipeline job. The next item are multi-configuration projects, and these jobs are meant for pipelines targeting multiple baselines or multiple platforms. So for instance, you might offer a software product like a mobile app, but that mobile app is offered on not only Android but also iOS, then you need to have a software development workflow that includes testing on both iOS platforms and Android platforms, and this multi-configuration project would help you do that. The next item in the list technically isn't a job, it's simply a container that stores other items. It could be a nested folder, or it could be a job inside of a folder. It's a way of grouping jobs into a directory-like structure. The next item is the GitHub organization item, and I'm not sure why it shows up twice here, but the GitHub organization item comes from the GitHub branch source plugin. And this plugin allows Jenkins to scan a GitHub user accounts repositories or a GitHub organizations repositories in GitHub. And for each repository in the organization or the user account that contains a Jenkins file, Jenkins will automatically create a job for that repository. And the plugin will also scan branches of a GitHub repository, and for each branch that contains a Jenkins file, it will also create a dedicated job for that Jenkins file. And for the last item here, the multi-branch pipeline job, it's somewhat similar to the GitHub organization because it allows you to define a code base which might not be located in GitHub. Maybe it's located in GitLab or another source code management system, for instance. And when you set the code base that you want this job to scan, it will scan each of the branches in that code base. And for every branch that has a Jenkins file in it, it will automatically create a Jenkins job dedicated to that branch. So now that we're somewhat familiar with the types of jobs that we can create in Jenkins, let's navigate back to the dashboard. And the next key component of the Jenkins interface that you should be familiar with is the Manage Jenkins page. So in the Manage Jenkins page, we can control just about every aspect and every configuration there is associated with our Jenkins instance. So let's go ahead and take a look at what's contained inside of this page. So in the first section of the Manage Jenkins page, we have the system configuration. And under System Configuration, we can select Configure System. The Configure System page is the central place where you can update the configuration of Jenkins, and you can also update the configuration of plugins as well on this page. So one configuration here that is worth noting is the number of executors, and you can see here that the number of executors is set to 2. When a Jenkins job is ran, we call a running instance of a Jenkins job a build. So a Jenkins job can produce a build. And in order for a build to execute, it needs an executor. An executor is essentially a thread that can execute the instructions outlined in a particular build. Right now, I've configured this Jenkins instance with 2 executors, which means that I can have up to 2 builds running in parallel. So it could be 2 builds of the same job, or it could be 1 build for one job and another build for a different job. But I can have a maximum of 2 builds running in parallel. So if I were to increase the number of executors to, like 50, then I would have essentially 50 available threads that I could schedule builds on, and I could have up to 50 jobs running in parallel. Now, do you want to set the number of executors that high? Probably not, unless you have a large amount of resources. When I say resources, I mean CPU and memory and disk space as well. Because as you increase the number of executors, you're also potentially increasing the resource usage that's happening on your Jenkins instance. So you need to be very careful with this configuration setting. And in my case, I'm going to leave it at 2. Another configuration that's also worth pointing out is the home directory, or the Jenkins home directory, which right now is in home, moss, and then the .jenkins folder. The .jenkins folder contains all of the data related to this particular Jenkins instance. It contains all of the jobs metadata, the artifacts of particular builds, and if I were to delete this .jenkins folder, I'm essentially blasting this Jenkins instance away. All of the data associated with this Jenkins instance would be gone. And if I were to delete that .jenkins folder and then rerun that Java command to start Jenkins, it would essentially be a fresh Jenkins instance. And as I scroll down in the configure system page, you'll see other settings like the Jenkins, where Jenkins is located in the Jenkins URL. But you'll also see configurations for particular plugins. For instance, the GitHub plugin, which allows me to add GitHub servers. These might be the GitHub server out on the public internet, github.com, or it could be an on-premise instance of a GitHub server, on your internal corporate network. So let's navigate back to the Manage Jenkins page, and then we'll navigate to the Global Tool Configuration page. And the tool configuration page allows us to specify installations or versions of tools that we would need in order to build and test our code inside of a Jenkins job. So for instance, we can specify a particular version of the JDK to be installed, and we can even add multiple versions of the JDK so that we can compile Java code inside of a Jenkins job. And we can also specify a particular Git installation so that Jenkins can clone down a code base and build a particular code base from a source code management system that's using Git. And there's other tools as well that we can add installations for, like Gradle, Ant, and Maven. So coming back to the Manage Jenkins page, under System Configuration, we can also manage plugins that are installed in Jenkins. So from the Manage Plugins page, we can update plugins. We can see what plugins are installed on the machine, and we can also search for plugins that are not installed. And there are hundreds of plugins that extend Jenkins functionality that we can install through this page. So let's navigate back to the Manage Jenkins page, and then under the Security section, I'm going to select Configure Global Security. And on this page, we can specify the method by which users would authenticate to this Jenkins instance. And in our case, Jenkins is using its own user database to authenticate users. And right now in this database, there are only two users. There's the admin user, and then there's one other admin user called Moss, which I'm currently signed in as. And these two users exist inside of this Jenkins owned database. Now, we can utilize other methods of authentication. For instance, if this Jenkins instance was inside of a corporate network that utilized LDAP, we could also integrate this Jenkins instance into the LDAP service in our corporate network. In addition to configuring an authentication method, we can also select an authorization strategy like matrix-based security, which will allow us to define more granular authorization levels inside of our Jenkins instance. Now let's navigate back to the Manage Jenkins page, and under the Security section, we also have Manage Credentials. And the Manage Credentials page allows us to store credentials that Jenkins might need in order to communicate with various services during a particular Jenkins build. For instance, when a Jenkins build starts, it typically has to clone down a code base from a source code management system. And in order to do so, it has to authenticate with the source code management system. And oftentimes it'll do so using an SSH key pair. And you can store the private key of the SSH key pair in this Manage Credentials section of Jenkins so that when the build runs, it will reference the private key stored in the Manage Credentials page in order to authenticate with the source code management system and clone down the repository to the local Jenkins workspace. And from the Security section, you can also create, delete, and modify users that are able to log into the Jenkins instance. And from the Manage Jenkins page, we can also monitor the Jenkins instance using the pages listed under status information. We can look at the system log. We can also review the resource utilization like CPU and memory that the Jenkins server is using on this particular machine. And we can also perform administrative tasks like restarting the Jenkins instance or shutting the Jenkins instance down. So hopefully you're a little more comfortable now navigating the Jenkins interface. And in the next video, we're going to install and configure the Maven plugin. So I'll see you in the next video, and thanks for watching. Hey, what's up everybody? My name is Moss, and welcome back to our tutorial series on Jenkins. By now you should have a good understanding of what Jenkins is, and you should also be familiar with some of the key elements of the Jenkins interface. In addition, you should have a Jenkins instance up and running. If so, you're ready for the next topic. In this video, we are going to install and configure the Maven plugin on our Jenkins server. So first, what is the Maven Jenkins plugin? The Maven plugin is an open source Jenkins plugin that supports Maven 2 and Maven 3 projects. And this plugin adds an additional job type to Jenkins called a Maven project. If you recall from the previous video, I walked through the new item page which listed all of the possible job types you could create in Jenkins. And this plugin adds an additional job type to that list on the new item page called Maven project. And this Maven project job type provides an advanced integration between Maven and Jenkins. But the question is, why use the Maven plugin when we could also invoke Maven inside of a freestyle project? The Maven plugin greatly reduces the configuration required for Maven projects inside of Jenkins. And the plugin enables post-build deployment of binary artifacts that are produced during a Maven build. In addition, the plugin provides graphical test reports directly in the Jenkins UI. It also supports incremental builds so as not to waste resources. We can also build modules in parallel and distribute it across executors and Jenkins nodes. The plugin also provides an additional build trigger in the Maven project job type. If it's enabled, Jenkins will parse the POM files of the current project. If any of the dependencies listed in the POM file are built on this Jenkins instance, then Jenkins will set up a build dependency relationship so that anytime the dependency job is ran, any downstream jobs that have that dependency listed in their POM file will also be triggered to run. Now that we have a better understanding of what the Maven plugin does, let's go ahead and install it on our Jenkins instance. Okay, so the first thing that I want to do is navigate to the Manage Jenkins page. And under System Configuration, I'm going to navigate to the Global Tool Configuration page. And I'm going to scroll down to Maven, and I'm going to select Add Maven Installation. And we'll give it a name, we'll call it Maven 3. And I have the option to either install this automatically, or I can specify a pre-existing installation of Maven on this machine. So in the Maven home field, I would just specify the directory where Maven is installed on this machine. I don't have Maven installed on this machine, so I'm just going to select Install Automatically. And the default installer is installing from Apache. And then I have the option to select which version I want to install. In this case, the latest version is already selected, so I'm going to leave it as is. And since I selected Install Automatically, during the first build of a Maven project on this Jenkins instance, Jenkins will download and install Maven. So the first build of a Maven project on this Jenkins instance might take a little bit longer because it's downloading Maven, but all following builds won't take as long because Maven is already installed on this Jenkins instance. So now that I've specified Install Automatically, I'm going to select Save. And in the Manage Jenkins page, I'm going to navigate to the Manage Plugins page. And I'll select the Available tab. And we're going to search for the Maven plugin. Okay, and it's the first result here called Maven Integration. I'm going to select that. And then I'm going to select Install Without Restart. And now that it is downloaded and installed, I'm going to select Restart Jenkins when installation is complete and no jobs are running. And so now Jenkins is restarting, and when it reloads, we should be able to see the Maven project job type shown in the new item page. Okay, so I'm going to go ahead and log back in. and I'm going to navigate back to the dashboard. And from the dashboard, I'm going to select a new item. And you'll notice below the freestyle project, we now have a Maven project job type in addition to the other jobs that we can create in this Jenkins instance. So I'll go ahead and create a sample project, and we'll just call it test Maven. And I'm going to select the Maven project job type, and I'm going to select OK. And there's a couple of things I'll point out in this configuration page. The first is under build triggers. So the first option here is the additional build trigger that I was talking about in the PowerPoint slide. So we can add a build trigger to build this Maven project whenever a snapshot dependency is built. And so this is the dependency that is listed in the POM file for this particular Maven project. And the other key element of this configuration page is under the build section, and here we specify where the root POM is located, and we can also specify Maven goals and options in this field. So for instance, I could say clean, compile, and test here. We can also add pre and post steps as well. And in an upcoming video, we'll use an actual Maven project with this Jenkins job type. But before we do that, we'll want to integrate this Jenkins instance with our GitHub account so that Jenkins can clone down the Maven project code base locally to the Jenkins workspace and build it. So what we'll target in the next video is setting up the integration between this Jenkins instance and our GitHub account. We have the Maven plugin installed and ready to go on this Jenkins instance, so I'll see you in the next video. Hey, what's up everybody, and welcome back to our tutorial series on Jenkins. In the last video, I walked you through the installation of the Maven integration Jenkins plugin. Before we utilize that plugin, we're going to build some additional automation on our Jenkins instance. So let's take a look at the next topic. In this video, we're going to integrate our Jenkins instance with our GitHub account. You probably remember this diagram from an earlier video describing the Jenkins architecture. What we'll be focusing on in this video is automating the trigger build and publish results steps in this sequence diagram. After automating these two steps, when a developer pushes a commit from their local machine to a GitHub repository, or when they make a commit directly in GitHub, what should happen is GitHub should trigger a Jenkins build for that GitHub repository. After the build is triggered, Jenkins will clone down the GitHub repository to its local workspace. And once the build finishes, Jenkins should automatically publish the results back to the GitHub repository. So what are some of the benefits of integrating Jenkins and GitHub? Some of these benefits you may have already guessed, but the first benefit is that it gives Jenkins the ability to clone a code base down to the local workspace so that it can build and test the code. The second benefit is that GitHub will push new changes to Jenkins and trigger builds rather than having Jenkins consistently poll GitHub repositories for new changes. Polling for new changes too frequently can be quite resource intensive on the GitHub server, and the GitHub API will actually rate limit you if you poll too frequently. The third benefit is that Jenkins will be able to perform GitHub operations, which would include doing things like publishing the build result to a GitHub pull request and to individual commits. There is one key prerequisite that I would like to point out for this integration. In order for the integration to work as described, GitHub must be able to send data to Jenkins. And since I'm using a github.com account, that means that the Jenkins instance must have a public IP. The only exception to this is if you're working on a Jenkins instance that's inside of your corporate network and you have an on-premise GitHub instance also inside of your corporate network. Now that we've covered those details, let's get started with the integration. Okay, so the first thing that I want to do is navigate to my GitHub account, which I'm already in my account. And then once you're in your GitHub account, you're going to want to go up to the profile dropdown and then select settings. And under settings, we're going to navigate to developer settings. And then we're going to navigate to personal access tokens. And we're going to generate a new token, a new personal access token. Okay, we'll call it Jenkins. And after giving it a name, we have to select scopes for this token. And what scopes do is they provide a level of authorization to what your GitHub account has. So for instance, your GitHub account has access to all of your private repositories, for instance. And you can grant this token access to your private repositories, or you may not want it to have access to your private repositories. Maybe you only want it to have access to public repositories. And as we select each one of these scopes, we're adding additional levels of authorization to our GitHub account for this particular token. And for this integration to work, I'm going to be using a public GitHub repository. So the only scope that I need to select in this case is the public repo scope, which will grant this token access to public repositories. I'm going to leave all of the other scopes unchecked, and then I'm going to select Generate Token. Now on this next page, the token value is presented to us, and you're going to want to copy this value, maybe save it in a text file temporarily, but not permanently, but at least copy it to your clipboard because we're going to use it inside of Jenkins. So I'm going to select the clipboard here, which will copy the token value. And I'm going to navigate to my Jenkins instance, which I already have pulled up. And in Jenkins, I'm going to select Manage Jenkins. And then under System Configuration, we'll go to Configure System. And then I'm going to scroll down to the GitHub section. Okay. And this GitHub section is for the GitHub plugin, which should have been automatically installed if you selected Install Recommended Plugins when installing Jenkins. So the two plugins that are required for this integration are the GitHub plugin and the Git plugin, and both of those are installed as part of the recommended plugins when you're first installing Jenkins. And in the GitHub plugin configuration, we can add GitHub servers that we want to authenticate with. And the one that we're going to authenticate with is already automatically filled out here. So we're going to be authenticating with the public GitHub API. And I'm just going to call it GitHub. And once we've specified a name and the API URL, we also have to specify credentials to authenticate with our GitHub account, right? So we need to provide credentials to authenticate with our GitHub account. And this is going to be our personal access token that we just created. So I don't have any credentials created on this Jenkins instance right now. So what I'm going to do is I'm going to select Add, and I'm going to select the Jenkins credential provider. And on the Add Credentials page, I'm going to specify the kind of credential that I want to create, which in this case is going to be secret text. Okay, so the personal access token is considered a secret text credential. Okay, I'm going to leave the scope the same. And then for the secret, I'm going to paste in the personal access token value. And we'll give it an ID. We'll call it GitHub PAT. I'll leave the description blank, and then I'll select Add. Okay. Now in the dropdown, we have the PAT credential that we can select. So I'm going to go ahead and select that credential. Now, once we've added our credentials, we can test the connection to the GitHub API. So I'm going to go ahead and click Test Connection. And you can see that it says credentials verified for user tech with Moss. And then it specifies the rate limit and how many API calls I have left. So it's set at 5,000, and I just used one to test the connection. So I have 4,999 API calls remaining before I'm rate limited. And the last configuration here is the Manage Hooks configuration. And when this is checked, Jenkins will basically automatically add the Jenkins webhook endpoint to the GitHub repository so that GitHub can then send data back to Jenkins. What we're going to do is we're going to manually add the webhook to our GitHub repository rather than have Jenkins automatically do it. So I'm going to uncheck this, and then I'm going to select Save for this configuration. And now that we've added that personal access token to this Jenkins instance, Jenkins should be able to communicate to GitHub and publish build results to a GitHub repository. But one thing to note is that I used my personal GitHub account credentials so that Jenkins could authenticate with GitHub, but it is a best practice to use something like a service account or a generic account, maybe an account that's called like Jenkins-CI or something like that, and then use that account's credentials to facilitate this particular automation. The next step is to create an SSH key pair, and we're going to add the public key to our GitHub profile and then add the private key to this Jenkins instance. And that will allow this Jenkins instance to clone down repositories to the local Jenkins workspace. So any GitHub repositories that my GitHub account has access to, this Jenkins instance will also have access to and be able to clone down when a build starts. So I'm going to open up a git bash session to generate the SSH key pair. And in my git bash window, I'm going to use SSH keygen to generate the key pair. And I'm going to accept all of the defaults. It asked me to overwrite my key pair. I'm just going to do that. And so I generated a key pair, and I'm going to cat the public key. Okay, so there's my public key, and I'm going to copy that public key to my clipboard. And then I'm going to navigate back to my GitHub profile. And in the settings menu of my GitHub profile, I'm going to go down to SSH and GPG keys. And I'm going to select new SSH key. And I'm going to paste in my public key. And I'll give it a name. I'll just call it Jenkins public key. Okay, so that added the public key to my GitHub profile, and I'm going to navigate back to Jenkins, and I'm going to open up the git bash window again. Now I'm going to cat the private key, and I'm going to copy the contents of the private key. Okay, so this is the private key, and I'm going to go ahead and copy that to my clipboard. Okay, and in Jenkins, I'm going to navigate to Manage Jenkins, and then I'm going to go to the Security section, and I'm going to select Manage Credentials. I'm going to select Jenkins, I'll select Global, and then I'm going to select Add Credentials. Okay, and the kind is going to be SSH username with private key. I'll leave the scope as is, and we'll call it GitHub private key. Okay, I'm going to leave the username blank, and then for the private key, I'm going to enter that directly. Okay, so I'm going to paste the private key in there. I didn't create a passphrase for this particular key, so that's all I need. I'm going to select OK. Okay, so we added the private key to Jenkins. So Jenkins, when a build starts for a particular GitHub repository, it should be able to clone down the repository using this private key that we just added. So I'm going to go back to the Jenkins dashboard. So now that we've added the SSH private key to this Jenkins instance, let's go ahead and create a new Jenkins job. So I'm going to go to the new item page, and we'll call it test job. And I'm going to select freestyle project, and then I'll select OK. All right. And in the source code management section, I'm going to select Git, and then it prompts me to enter the repository URL. So this is going to be the URL of the GitHub repository. And I have created a very simple GitHub repository. All it has is a single README file in it. So I'm going to navigate back to my GitHub profile. Okay, I'm going to select my repositories. And then I'll select this repository, which is the one that I created. It's just a very basic repository with just a README file in the repository. And I'm going to select the code tab here, and it gives me the URL. So notice how I can select different URLs. I can select an HTTPS URL or an SSH one. Make sure that you select the SSH one because we're using an SSH key pair to clone down this repository. So we need the SSH URL and not the HTTPS URL. So I'm going to select the SSH URL. I'm going to copy that to the clipboard. And I'm going to navigate back to Jenkins. And I'll paste that in. Okay, so it says failed to connect right now. And it says permission denied. So I haven't specified the credentials that I want to use in order to clone this repository down. So in the credentials section, I'm going to select the private key that was just created, and it defaults the username. So I remember that I didn't enter a username here. It automatically entered a username for me. And so I'm going to select that. And notice that the error disappears after selecting the credentials, which means that it was able to authenticate successfully, so it can clone down this repository. The next configuration is under branches to build. I'm going to specify the main branch since that's the only branch I have in my GitHub repository. And once I've specified that, I'm going to scroll down to the build triggers section. And what the GitHub plugin provides is an additional build trigger, and it's this one right here. It's GitHub hook trigger for Git SCM polling. And it says here, if Jenkins receives a push GitHub hook from a GitHub repository that's defined in the Git SCM section, it will trigger the Git SCM polling logic. Okay, basically what this means is that if GitHub receives a push from a developer, so a developer pushes a commit up to a GitHub repository, GitHub will then automatically trigger this particular Jenkins job to build if this build trigger is selected. So we are going to go ahead and check that build trigger since we want that behavior. The next configuration that we're going to set is under post build actions. I'm going to select add post build action and then set GitHub commit status. Okay. And what this action will do is when the build finishes, Jenkins will communicate the build result back to the GitHub repository, and it will set the build status on the individual commits that were built during this particular Jenkins build, as well as the pull requests if there is an open pull request for the commits that were built in this particular Jenkins build. So I'm going to leave these two fields as their default values, and then under the what section, I'm going to specify the status result based on one of the default messages and statuses. So this status result basically allows me to manually define like what the status message will say based on the build result. So if I selected here result better than or equal to, let's say, success, I can provide a custom success message. But for my case, I'm just going to select the default messages in status. We don't necessarily need custom messages in this particular case. And this back reference will provide a link directly back to the build inside of GitHub. So that should be all of the configurations we need in this particular job. So I'm going to go ahead and select save. So now that we've created the Jenkins job, there's one last configuration that we need to make, and it's inside of the GitHub repository. So I'm going to navigate back to my GitHub repository, And in the repo, I'm going to select the settings page. And under settings, I'm going to navigate to the webhooks section. Okay. And webhooks allow external services to be notified when certain events happen in this particular repository. So I'm going to select Add Webhook. And the first field that is required is the payload URL. And this is the URL endpoint that GitHub will send data to. And in our case, it's going to be our Jenkins URL with a special endpoint added onto the base Jenkins URL. So I'm going to navigate back to Jenkins. I'm going to copy the base URL, which is right here. I'm going to paste that in, and then I'm going to add the endpoint for GitHub webhooks, which is GitHub-webhook, okay? And then /. The content type I'm going to select as JSON. I'll leave the secret blank. And then it allows me to select which events I would like to trigger this webhook for. And I can use just the push event. I can say for any event, send me everything, or I can say, let me select individual events. So maybe instead of the push event, I want this webhook triggered anytime a pull request is opened. And this particular selection will allow me to do that. So if I select this, then anytime a pull request is opened, closed, reopened, etc., an event will be triggered for this webhook, and that data, that event will be sent to Jenkins, and it will be sent to this particular endpoint that we provided here, okay? And I'm gonna leave it as is with just the push event being sent to the endpoint. That's really all we need right now. And I'll leave it as active, and then I'll select Add Webhook, okay? And when you select Add Webhook, it should automatically test the connection. So I'm gonna go back into the webhook, and you'll notice that under recent deliveries, we have this little check mark, and it tested the webhook, and that was successful. We got a successful 200 response back from Jenkins. So we configured this webhook correctly. So now that we've added the hook, we should be able to make commits locally on our machine and push them to GitHub, or make commits directly in the GitHub interface. And both of those actions, pushing commits as well as making commits in the GitHub interface, should trigger our Jenkins test job to run a build for this particular repository. So let's go ahead and try it out. I'm gonna navigate to the code tab, and I'm gonna make a commit directly in the GitHub interface. And I'm gonna just edit the README file, and I'll just say, okay. And then for the commit message, I'll just say testing Jenkins. And before I select commit changes, I want to show you that our test job currently doesn't have any jobs that have ran, or any builds that have previously ran, right? So after I select commit changes, we should see a build running in this Jenkins job. Okay, so I'm going to select commit changes, and let's take a look back at our Jenkins job. And you'll notice that we have a build currently pending in the Jenkins job, and it's already finished. So if I select refresh, we can take a look at the Jenkins job, and it successfully cloned down the test repo from GitHub. There wasn't really anything in the repo, and there wasn't anything to build, any code to build or test. So it didn't really do anything except clone down the repository. And then it performed the post-build action of setting the GitHub commit status in GitHub. So what does that look like in GitHub? Let's navigate back to the GitHub repository, and I'm going to select the latest commit here. And you'll notice that next to the commit message here, we have this small check mark. That check mark indicates the status of that commit, and it says all checks have passed. And then we also get a back reference to the Jenkins job itself So this details hyperlink goes back to the Jenkins job. So let me click that, and you'll notice that you'll see here that it goes back to the build in Jenkins. And I'll go ahead and navigate back to the GitHub repository. So this works for individual commits. If I were to look at the list of commits for a particular branch, you'll see that commits that triggered a build, if the build was successful, they'll get this small check mark next to them, and it says, build number 1 succeeded in this amount of time, and you get a back reference to the Jenkins build itself. This status also pops up in pull requests. So if you have a pull request for a commit or multiple commits, then Jenkins will also post the status inside of the pull request. And let's try that out real quick. I'm going to navigate back to Jenkins. And in Jenkins, I'm going to navigate to the job, and I'm going to make one configuration change. It's going to be to the branch specifier. And I'm just going to leave this blank. So this will build for any branch, not just the main branch if I leave it blank. So I'm going to navigate back to GitHub, and I'm going to go to the code tab. And in the code tab, I'm going to create a new branch. We'll call it Jenkins test branch. I'll select create branch. And I'll make a small modification to the README file. And I'll commit these changes. And as soon as I commit the changes, this should trigger a build in our Jenkins job. And it will trigger a build since I just modified the Jenkins job to build any of the branches in this repository, not just the main branch. So I'm going to navigate back to the code tab. And in the code tab, I'm going to select compare and pull request for my branch. I'll leave everything as is, and then I'll select create pull request. And you'll notice that on the pull request page, if I scroll down here, we have this status check, and it says all checks have passed, one successful check. And if I click show all checks, it will show me the test job name, and it specifies that build 2 succeeded in half a second. And then it provides a back reference to the build itself. So if I click details, it takes me directly to build number 2. Okay. So that about wraps it up for this integration. As you can see, it's a very useful integration for optimizing the CI/CD process. I hope you enjoyed this video, and I'll see you in the next one. Hey, what's up everybody, and welcome back to our tutorial series on Jenkins. In the last 2 videos, I showed you how to integrate GitHub with Jenkins, and I also walked you through the installation of the Maven integration plugin, which laid the groundwork for this video. So let's take a look at the next topic. In this video, we are going to create a Jenkins job for a Maven project. I'll quickly recap some of the key features of the Maven project job type. The Maven integration plugin provides a new job type in Jenkins called a Maven project. And the Maven integration plugin significantly reduces the manual configuration required to set up a Maven project in your Jenkins. Additionally, the plugin provides test reporting directly in the Jenkins interface. And with that, let's go ahead and get started. Okay, so the first thing that I wanted to do was quickly walk through the Maven project that we're going to build in our Jenkins server. And I have the Maven project pulled up in my GitHub account. It's called Sample Maven Project, and it's a very basic Java application. And I actually generated this code base automatically using the Maven Quick Start archetype. And if we take a look at the Quick Start archetype, it will generate a sample Maven project for us with a very simple structure. And if we take a look at the directory structure, it begins with a top-level pom.xml file. Then we have the source directory, and inside of the source directory, we have a single app class. And then we also have a test directory, which contains the app test class that tests this app class. So if we navigate back to the GitHub repository, we can take a look at the app class and see what it does. So if I navigate to the app class, it's very simple. It just prints out hello world to the console. And then if we go back to the test directory and open up the app test class, this is also very simple. It's a single JUnit test. It's assert true with an always true condition. So it should always pass. So this is the code base that we want to build in our Jenkins instance. So let's navigate to Jenkins and we will create a new Maven project. So opening up Jenkins, and then I'm going to select the new item page, and I'm going to call it Test Maven Project. And then I'll select the Maven Project job type, and I'm going to click OK. And the first thing that we want to do is set up our source code management. And so I'm going to scroll down to the SCM section, and then I'm going to select Git. And then we need the repository URL. And remember that this is going to be the SSH URL for the repository. So I'm going to navigate back to the GitHub repository, and I'm going to copy the SSH URL. And I'll paste that into the repository field. Okay, and I get a permission denied error, which means that I haven't selected the credentials to use to clone down this repository. So I'm going to select my SSH private key that was previously added. And you can see that the error disappears after selecting the private key, the SSH private key. The next thing that I'm going to update in this configuration is the branch specifier. I only have the main branch in this repository, so I'm going to just update that to main. And the next configuration that we're going to update is the build triggers. And you may remember me discussing this first build trigger, build whenever a snapshot dependency is built, when we were first installing the Maven integration plugin. But essentially, whenever this build trigger is checked, any snapshot dependency that is defined in this project's POM file is built on this Jenkins instance. So if any other dependencies defined in the POM file are built on this particular Jenkins instance, then those dependency builds will trigger a build for this job that we're defining now. And although there aren't any dependencies being built on this Jenkins instance for this particular project, I am just going to leave it checked since it's checked by default. The next trigger worth noting is the build after other projects are built trigger. It's somewhat similar to the first build trigger, but when I have this trigger selected, it allows me to specify a list of jobs on this Jenkins instance. And when those jobs are built, it will trigger a build for the current job that we're defining. And there is a second condition that I can specify here to trigger only if the build in the project specified in this field are stable, or I can trigger it even if the build is unstable in these projects that I defined here, or I can trigger it even if the builds fail in the projects that I defined in this field. This trigger might be useful if you have multiple jobs and each job only performs like a single task, and it's like a pipeline of jobs that you want to run in succession. But in this case, we don't really need that. And even if you did have multiple jobs like that are kind of like a pipeline of jobs, it would be preferable to just write a pipeline script and have a single pipeline job to handle those individual tasks. So I'm going to go ahead and uncheck this build trigger. The next build trigger is build periodically. And this trigger allows you to schedule this job on a predefined cadence. And you can use cron style syntax in this field to specify how often this job will build. So for instance, if I wanted this job to build every minute, I would use this syntax. And you can see here it says, do you really mean every minute? When you say, 5 stars there, perhaps you meant hourly. Okay, so this would be the syntax for running this job hourly. And I think this build trigger is particularly useful when you use it for your release cycle cadence. So for instance, you might want to have like a nightly build of your main branch, or you might have a weekly build of your main branch, or you might have a release at the end of every sprint. So maybe you want to schedule this for every 2 weeks or every 3 weeks. And I think that's where this build trigger is most useful. In this case, I'm not going to utilize this trigger, so I'm going to go ahead and uncheck it. The next trigger is the GitHub hook trigger for Git SCM polling. And this is the trigger that we set up in the previous video. So when this is checked, anytime a developer pushes a commit to GitHub or makes a commit directly in the GitHub interface, an event is sent to Jenkins that will trigger this job for the code base that they push that commit to. And I am going to utilize it for this Maven project, so I'm going to go ahead and check it. And the last build trigger is pull SCM, which is kind of the opposite of the GitHub hook trigger, because it allows you to schedule a predefined cadence for Jenkins to pull your source code management, whether it be GitHub or another source code management system, for new changes. I've mentioned this in previous videos, but using this build trigger is kind of a bad practice. You don't necessarily want to pull your SCM system. If you do, you want to do it infrequently, maybe like once a day. Probably once a day would be like the most frequent, maybe once an hour, but in general, polling the SCM system is bad because you're consuming resources on the SCM system, and you're also consuming resources on this Jenkins instance to query or make a query to the source code management system to check if there's any new changes. So it's really a best practice to always set up, if possible, the GitHub hook trigger if you're using GitHub, or if you're using another SCM system, use some sort of webhook that will push new changes to Jenkins rather than having Jenkins pull the SCM system. So I'm going to go ahead and uncheck this pull SCM option. Now remember, we do have to set up the webhook inside of the GitHub repo if we select this option. So after we save this new Maven project, we'll go ahead and add that webhook to our GitHub repository. The next configuration that we want to set up is the build configuration. And under the build section, we can specify where the root POM is located. And here we can leave this value as is, since the POM file is at the root directory of our Maven project. And on the second field here, we can specify goals, Maven goals, and options. So for instance, I can specify clean install in this field. And if I were to leave the field blank, it would perform an install by default. It would perform the install lifecycle. But I could also specify deploy here if I had a remote repository that I wanted to send the generated artifacts to. But I'm going to go ahead and leave this as clean install. So that should be the bare minimum configuration that we need for this Maven project. So I'll go ahead and select save. And before we build this project for the first time, I want to add the webhook to our GitHub repository. So I'm going to copy the address here. So we'll copy the port. And then in the GitHub repository, we'll navigate to settings. And in settings, we'll select webhooks, add webhook, and then the payload URL will be the URL of the Jenkins server and the GitHub webhook endpoint. Okay. And I'll select JSON, and we'll leave the default selection. So this will send the push event to Jenkins, and we'll leave it as active. I'll select add webhook. Okay. And if I select the webhook, we can see under recent deliveries that it was a successful delivery. So we know it's configured correctly. And now let's navigate back to our Jenkins instance. Now let's build the project for the first time. So I'm going to select build now. And let's take a look at build number 1. So it performed the Maven clean, it compiled, and then it ran the single test case and the app test class. And then it performed the install as well. So it archived the snapshot jar in the local repository. And what's neat, if we take a look back at the project page itself, after the build runs, we get this test result trend, which shows the duration of the tests on the y-axis and then the build number on the x-axis. So if I hover over this single data point here, we can see that build number 1, 1 test passed and 0 tests skipped and 0 tests failed. And additionally, if I go into the build itself, we also get kind of a test report inside of Jenkins. So if I take a look at the test result, we can drill down into the module, the package, and then the test class itself, and then look at all of the tests within a single class and take a look at whether or not they passed or failed. And if the test failed, then we can also get the stack trace directly in this interface as well. So we could see the stack trace and get a little bit more details on the failure. And from the build page, we can also access build artifacts. So as you can see here under build artifacts, I can download the snapshot jar or the snapshot palm locally to my machine. And this would be especially useful if you wanted to perform manual testing after automated testing occurs on the generated snapshot. And just for the sake of it, let's update our test case to fail just so that we can see what the test report looks like when a test case fails. So I'm going to navigate back to the GitHub repository, and I'll navigate to our test directory. And this will also exercise our webhook as well, or it should if our webhook is working correctly. I'll open up the test class, and I'll directly modify it in the GitHub interface. We'll change that condition to false. Okay, and then I will commit that change. So let's take a look back at our Maven project in Jenkins, and let's see if it successfully triggered a build. And it took a little while for the Jenkins interface to update, but it did trigger a build. And as you can see, for build number 2, it is unstable. The yellow mark indicates that it's an unstable build, and unstable means that one or more test cases failed. And if we take a look at the test result trend, we can also see that build number 2 is represented in the graph, and in build number 2 we have 1 failed test case. And I'll quickly open up the build number 2 page, and if I select the test results, you can see the number of failures is listed up here, that there was 1 failure, and then it lists the failed tests. And if I expand this out, I can expand the stack trace for this failed test, and it's a pretty simple one. All it says is that there is an assertion error because the condition that we selected was, or that we added to this test case, was false. So that's all I have for this video. I hope you enjoyed it, and in the next video I'm going to walk you through the process of setting up a Jenkins controller and Jenkins agent nodes. So I will see you in the next video. Hey, what's up everybody, and welcome back to our tutorial series on Jenkins. In the last video I showed you how to create a Jenkins job for a simple Maven project. And our Jenkins server has no problem running this job or really any of the jobs that we've created in the previous videos. But in a corporate environment, Jenkins jobs might consume a significant percentage of resources on the machine that's hosting the Jenkins server, especially when there are many jobs ran in parallel. So let's take a look at our next topic that will help mitigate this challenge. In this video, we are going to configure Jenkins Controller and Jenkins Agent nodes. And before I walk you through the configuration steps, I first want to discuss the problem that we're trying to solve. As software teams and their organizations grow, so does the need to scale Jenkins. In addition, software teams may need to build and test software on multiple platforms, like Windows, Mac OS, and Linux. And a single Jenkins instance will likely be unable to meet these requirements. In order to meet these requirements, we must scale Jenkins up and/or out. Jenkins can support organizational growth as well as the need for multi-platform build and testing through the use of agents. Jenkins agents are machines that the Jenkins controller can delegate the task of building projects to in a distributed manner. An agent node might be a Windows machine, a Linux machine, or some other platform that supports Java. This allows multi-platform build and testing using the same Jenkins server, and it also allows us to scale our Jenkins out as needed. All we need to do is add additional agent nodes. If we take a look at the architecture shown here, the Jenkins controller node is the Jenkins server that we've already configured in previous videos. We will be adding a Windows agent node in this video. After we've configured our Jenkins agents, the Jenkins controller will be able to schedule builds on Jenkins agents according to the Jenkins Job configuration. Now that we've covered those details, let's get started. So the first step to set up our Jenkins controller and Jenkins agent nodes is to create an SSH key pair. I have my terminal up already. I'm using git bash, and in git bash I'm going to use the SSH keygen command to generate a new key pair. And I'll call it Azure Jenkins agent. And I'll leave the passphrase empty. Okay, so that generated a new key pair. And I'm going to cat the private key. And I'm going to copy the contents of the private key. And then I'm going to navigate to Jenkins. And in the Jenkins controller, I'm going to navigate to Manage Jenkins. And then we'll navigate to Manage Credentials. We'll open up the Jenkins credential store and then Global Credentials. And then I'm going to select Add Credentials. And then the kind of credential that we're going to use is SSH username with private key. And we'll give it an ID. We'll say it's Azure Jenkins agent. And the username is going to be Azure user. And then the private key will enter directly. And I'll just paste the private key into that field. Okay. And then I'll select OK. The next step is to copy our public key to the machine that is going to be our Jenkins agent hosted in Azure. And I already have an SSH session open with that machine, so I'm going to open up that session. And I'm currently on the logged onto the machine or the VM that will be running as a Jenkins agent. And I'm going to modify the authorized keys file and add the public key that we just created. Okay. So in the other terminal window, I'm going to cat the public key. And I'll copy the public key value. And I'll add this public key to the authorized keys list. And then we will save that file. So now we should be able to SSH, or this Jenkins instance should be able to SSH to this VM hosted in Azure. So we can begin configuring this Azure VM as a Jenkins instance inside of our Jenkins controller. So I'm going to navigate back to the Jenkins dashboard. And from here, I'm going to navigate to Manage Jenkins. And then I'm going to select Manage Nodes and Clouds. So we're going to create one additional node, and I'm going to use this Windows PC as the second node. So I'm going to select New Node, and we'll call it Windows Agent. I'll select Permanent Agent, even though I do have the option to copy from an existing node. And I'll select OK. I'll leave the number of executors at 1, and then I'll use the same remote root directory. I'll just call it Jenkins Agent Data. And for labels, I'll use the Windows label. Usage, I'll leave usage as default. And then the launch method, we'll use launch agent by connecting it to the master. And one reason, besides just to demonstrate this launch method, one other reason to use this launch method is because this Windows PC is on my home network, and the Azure VM has a public IP, and it's accessible. So I can use the SSH connect to via SSH in that case, because port 22 is open and the IP for that Azure VM is public. But for this Windows PC, the IP address is not public, and by using this launch method, I can start the agent program locally and then specify the IP address of the controller and establish a connection, an outbound connection to the controller that way, since the controller does have a public IP address. I'll leave the rest of the configurations for this launch method as default. Same for the availability, and then I'll select Save. So now you can see that the Windows agent has been added, but there is an X over the node indicating that Jenkins is not connected with it. And if we click on the agent, it says that the JNLP agent port is disabled and agents cannot connect this way. And it even tells us where we need to go to update the configuration so that this works correctly. So I'm going to follow this hyperlink, and this takes me to the global security page of Jenkins. And if I scroll down to the agents section, I have to enable a TCP port for inbound agents. And I can select random or fixed, and I'm going to select fixed. And I'm going to enter just a high value port number that I know is not being used. And then I'm going to select save. Now I'll select Manage Nodes and Clouds, and I'll select the Windows agent again. And now you can see that it tells us at the top we can connect to the agent using one of these ways. And the first, we can run from the agent command line this command. And this is the command that we're going to use to run the agent program on this Windows PC. So I'm going to copy this command to my clipboard, and I'm going to download the agent.jar file locally. And now that we have that downloaded, I'm going to open up a git bash session, and I'll navigate to the directory where the agent.jar file was downloaded. And I'm going to paste the command into the session, and we'll run it and see if the agent connects successfully. Okay, and it looks like it did connect. It says that it's connected right there. So I'll refresh the page, and it says that the agent is connected. I'll navigate back to the dashboard. We'll create a new item, and we'll call it Test Windows Agent. I'll select Freestyle Project, and then I'll select Restrict where this project can be ran, and I'll use the Windows label this time. And in the build section, I'm going to add a single build step, execute shell, and we'll say echo hello world to hello world.text, and we'll select save, and then let's go ahead and build this job. Okay, so I'll navigate into the job console output, and you can see at the top of the console output, it's building remotely on the Windows agent using the Windows label, and then it specifies the workspace that it's using on my local Windows PC. And it looks like it was successful with the echo command as well. We can quickly verify that in git bash. So if I cd to downloads and then Jenkins agent data, I'll cd into the workspace, and then I have the job directory. And if I cd into the job directory, we can see the hello world.txt file did get created. And if I cat that, the hello world is in that text file. Hey, what's up everybody, and welcome back to our tutorial series on Jenkins. In the last video, I showed you how to create a Jenkins job for a simple Maven project. And our Jenkins server has no problem running this job or really any of the jobs that we've created in the previous videos. But in a corporate environment, Jenkins jobs might consume a significant percentage of resources on the machine that's hosting the Jenkins server, especially when there are many jobs ran in parallel. So let's take a look at our next topic that will help mitigate this challenge. In this video, we are going to configure Jenkins Controller and Jenkins agent nodes. And before I walk you through the configuration steps, I first want to discuss the problem that we're trying to solve. As software teams and their organizations grow, so does the need to scale Jenkins. In addition, software teams may need to build and test software on multiple platforms, like Windows, Mac OS, and Linux. And a single Jenkins instance will likely be unable to meet these requirements. In order to meet these requirements, we must scale Jenkins up and/or out. Jenkins can support organizational growth as well as the need for multi-platform build and testing through the use of agents. Jenkins agents are machines that the Jenkins controller can delegate the task of building projects to in a distributed manner. An agent node might be a Windows machine, a Linux machine, or some other platform that supports Java. This allows multi-platform build and testing using the same Jenkins server. And it also allows us to scale our Jenkins out as needed. All we need to do is add additional agent nodes. If we take a look at the architecture shown here, the Jenkins controller node is the Jenkins server that we've already configured in previous videos. We will be adding a Linux agent node in this video. After we've configured our Jenkins agents, the Jenkins controller will be able to schedule builds on each of the Jenkins agents according to the Jenkins job configuration. I'll briefly summarize the environment that I will be using in this video. The Jenkins controller and one of the Jenkins agent nodes are hosted on Azure. One additional agent will be ran on my Windows PC. The Jenkins controller and Jenkins agent nodes hosted in Azure both have public IPs. Additionally, port 22 is open for inbound traffic on the Azure agent. One thing I'd like to point out is that we won't be using the Azure VM agents or AWS EC2 Jenkins plugins. These plugins allow you to dynamically provision agents in the cloud. You may be wondering why we aren't using these plugins, and it's not because they aren't useful. These are very useful plugins. But the method that I'm going to show should be cloud agnostic and can be applied in an on-premise environment or without a cloud account. You could even set this up to run entirely on a single machine. Now that we've covered those details, let's get started. So the first step to set up our Jenkins controller and Jenkins agent nodes is to create an SSH key pair. I have my terminal up already. I'm using git bash, and in git bash I'm going to use the SSH keygen command to generate a new key pair. And I'll call it Azure Jenkins agent, and I'll leave the passphrase empty. Okay, so that generated a new key pair, and I'm going to cat the private key. And I'm going to copy the contents of the private key. and then I'm going to navigate to Jenkins. And in the Jenkins controller, I'm going to navigate to Manage Jenkins. And then we'll navigate to Manage Credentials. We'll open up the Jenkins credential store and then Global Credentials. And then I'm going to select Add Credentials. And then the kind of credential that we're going to use is SSH username with private key. And we'll give it an ID. We'll say it's Azure Jenkins Agent. And the username is going to be Azure User. And then the private key will enter directly. And I'll just paste the private key into that field. Okay. And then I'll select OK. The next step is to copy our public key to the machine that is going to be our Jenkins agent hosted in Azure. And I already have an SSH session open with that machine, so I'm going to open up that session. And I'm currently on the logged onto the machine or the VM that will be running as a Jenkins agent. And I'm going to modify the authorized keys file and add the public key that we just created. Okay. So in the other terminal window, I'm going to cat the public key. And I'll copy the public key value. And I'll add this public key to the authorized keys list. And then we will save that file. So now we should be able to SSH, or this Jenkins instance should be able to SSH to this VM hosted in Azure. So we can begin configuring this Azure VM as a Jenkins instance inside of our Jenkins controller. So I'm going to navigate back to the Jenkins dashboard. And from here, I'm going to navigate to Manage Jenkins. And then I'm going to select Manage Nodes and Clouds. And as you can see from this list, there's currently only one node configured for this Jenkins instance, and it's the machine that this Jenkins server is currently running on. And we're going to add 2 additional nodes. The first node is going to be our Azure VM. And to add an additional node, I'm going to select the New Node button here, and I'm going to provide a name for the node. We'll call it Azure Agent. And then I'm going to select that this is a permanent agent. And this is a permanent agent as opposed to an ephemeral agent, which could be dynamically provisioned and decommissioned. And after selecting permanent agent, I'm going to click OK. And it takes us to a configuration page where we can specify additional configurations for this new Jenkins agent. And it includes a description as well as the number of executors on the Jenkins agent. So the same as we can control the number of executors on the Jenkins controller, we can do so on the Jenkins agent so that it can have it can perform multiple builds in parallel. I'm going to leave the number of executors as 1 in this case. The next configuration is the root directory, and this is going to be the directory that the Jenkins agent caches all of its build data. And this can be a pre-existing directory or a directory that's created on demand. And in my case, I'm going to create a directory on demand, and I'm going to call it Jenkins agent data. And this directory is going to be created under the home directory of the Azure user, which is the user that Jenkins is going to be using to log into the Azure VM. The next configuration is very important. It's called labels. And labels are a way of categorizing your Jenkins agents. So for instance, you might have Windows nodes and Linux nodes. and it might be important to have certain jobs only run on the Windows nodes and other jobs run only on the Linux nodes. So for this agent, I'm going to specify a Linux label since the Azure VM is running a Linux image. The next configuration is the usage configuration, and we can specify whether to use this node as much as possible or only build jobs with label expressions matching this node. And that simply means that anytime a job specifies to build on certain labels, for instance, the Linux label, then those builds could be scheduled on this agent if it's online. And we will use the label expressions, but I'm going to leave it as the first option, use this node as much as possible. The next configuration is the launch method. And the launch method is a really important configuration when you're setting up a new Jenkins agent. And we have several options for launching a Jenkins agent. And the first option is launching an agent by connecting it to the master. And the master is the older verbiage, and now it's called the controller. So this is launching an agent by connecting it to the controller, the Jenkins controller. And the second option is launching an agent via execution of a command on the controller. And then the last one is launch agents via SSH. And for this particular Jenkins agent, I'm going to use the third option, launch agents via SSH. And for the second node, which is going to be my Windows PC, I'm going to use the first option, launch agent by connecting it to the controller. When we use the first option, Jenkins allows us to download an agent jar file, and that jar file is running the Java application that is the Jenkins agent. So we have to download the jar file to the Jenkins agent and then run the Java application inside of that jar file, which will establish a connection with the Jenkins controller. And with the second method, launch agent via execution of command on the controller, this allows us to specify a launch command in this field. And the command, if I expand the help text here, the command can be very simple. We could specify SSH, and then we could SSH onto the Jenkins agent node and run the agent jar file directly. Or we could invoke a script on the Jenkins agent node in the event that we have to set up environment variables on the agent node in order to run whatever builds that agent will be running. But in my case, I won't be using that launch method. I'm going to use the launch agents via SSH for this first Jenkins node. And in the host field, I'm going to specify the IP of the Jenkins agent node, which is an Azure VM. And I've already copied this VM's IP address, so I'm going to paste it into the host field. And then for the credentials, I'm going to select the private key that we created earlier in the video. For host key verification strategy, I'm going to select non-verifying verification strategy. And then for availability, I'm going to leave it as default, keep this agent online as much as possible. We have a couple of other options that we can use for availability, like bring this agent online according to a schedule, or bring this agent online when in demand and take offline when idle. So if I were to select that, I could specify an in-demand delay. And essentially what this means is it's the number of minutes, as it says here in the help section, it's the number of minutes for which jobs must have been waiting in the queue before Jenkins will attempt to bring this agent online. And then we can also specify an idle delay. And this is the number of minutes that the agent will remain idle before Jenkins will take it offline. So this availability strategy might be useful if you're trying to optimize your costs on the Jenkins agent nodes. But in my case, I'm going to select the first option, keep this agent online as much as possible. I'll leave the node properties unchecked, and then I'll select save. And now you'll notice that the Azure agent node has been added to our nodes list. And under the build executor status, we not only see the controller node and its 2 executors, but we can also see the Azure agent node and its single executor. And if we take a look at the logs on this Azure agent, we'll be able to see that the Jenkins controller successfully made an SSH connection to the Azure VM. And after it authenticated, if we scroll down a little bit, it copied the remoting.jar. And this remoting.jar is essentially the Jenkins agent program that will run on that Azure VM. And you'll also notice that it created the Jenkins agent data directory, since that didn't exist on the VM. And after it copied the jar file, it CD'd into the Jenkins agent data directory, and it started the agent jar file. And in the final line of the console output here, you can see that it specifies that the agent successfully connected and is currently online. So let's navigate back to the Jenkins dashboard, and I'm going to create a very simple job, and we'll call it Test Azure Agent. And this will be a freestyle project. I'm going to select OK. And in this job, I'm going to select restrict where this project can be run. And when I select that, I get a field label expression. And this allows me to specify a label that was previously created, like a label that was created when we were configuring the Jenkins agent, for instance. And when I specify a label, this job will only be ran on nodes that match those labels. So for the agent that we just created, I created a Linux label. So as I start typing Linux, it auto-completes, it recognizes the label that I previously created. And I'll backspace here. And then it says label Linux matches 1 node. So anytime this job runs, it should run only on our Azure agent node. And now that we've specified that label, I'm going to scroll down to the build section. I'm going to select add build step. I'll select execute shell, and I'll do something really simple here. I'll just echo hello world into a new text file. And then I'll select save. So now that we've created this job, let's go ahead and select build now. And I'll go ahead and open up the first build console output. And then you can see at the top of the console output here, it specifies that it's building remotely on Azure Agent with the Linux label, and it's building it in the following workspace. And it looks like the echo command did work correctly, but let's just verify it by logging into the VM and checking the workspace. So if I take a look at the VM, I have the Jenkins agent data directory. So I'll CD into that. And then I'll CD into the workspace. And I can see the job name Test Azure Agent. And I see hello world.txt. So if I cat that, and it does contain hello world inside of that file. So it looks like our first Jenkins agent is working correctly. So that's pretty much all I had for this video. And in the next video, we are going to discuss Jenkins pipelines. So I will see you in the next video. Hey, what's up everybody? My name is Moss and welcome back to our tutorial series on Jenkins. Until now, we've only created freestyle jobs and Maven jobs in our Jenkins server. But in industry, you'll need more than a single freestyle job to facilitate your full build and release process. And for these more complex use cases, Jenkins allows you to define your build and release process in Groovy code. In this video, I'm going to introduce you to Jenkins pipelines. Let's begin with a brief overview. As a team's software development process matures, it can become difficult to model the build and release process using only freestyle jobs in Jenkins. In order to mitigate the complexity of managing multiple freestyle jobs, the Jenkins Pipeline plugins allow you to model those complex build and release processes as groovy code in what's called a Jenkins file. So what are some of the benefits of using a Jenkins pipeline? If we check in the Jenkins pipeline code contained within the Jenkins file into version control, then we immediately get the benefit of traceability and control over changes made to the pipeline. The other benefit of version controlling the Jenkins file is that the pipeline exists independent of a Jenkins server, which means if for some reason the Jenkins server was accidentally destroyed, the pipelines would not be destroyed since they're managed in a source code management server. The other benefit of Jenkins pipelines is that they are highly extensible through the use of shared libraries and plugins. In addition, pipelines support logical operators such as conditionals, loops, and parallel execution. Let's also quickly discuss some key pipeline terminology. The first is the concept of a pipeline. A pipeline is a user-defined model of a build, test, and release process for a software product. The second term you should be familiar with is node. A Jenkins node is a machine that the Jenkins controller can execute pipeline jobs on. The next concept that you should be familiar with is a stage. A Jenkins pipeline stage is a logical grouping of steps that typically align with the build, test, and release portions of the software development lifecycle. So for instance, you might have a build stage, a test stage, and a deploy stage. You should also be familiar with the concept of steps. Steps are individual tasks completed within a stage of a pipeline. For instance, a single step could invoke a Jenkins node's shell and execute a command like ls or make directory on it. It's also worth mentioning the two types of Jenkins pipelines. There are declarative and scripted pipelines. Declarative pipelines are a newer feature of Jenkins pipeline, and declarative pipelines have richer syntactical features than scripted pipelines, which makes them easier to read and write. Now that we have a general understanding of what Jenkins pipelines are, let's get started. Okay, so I'm inside of my Jenkins server, and the first thing that I want to do is install a new plugin called the Pipeline Maven Integration plugin. Now to write a Jenkins pipeline, you don't need any additional plugins. All of the plugins that you need to write a basic Jenkins pipeline are included when you install Jenkins on a machine. But if you have a Maven project that you want to build inside of a pipeline script, it's good to install the Pipeline Maven Integration plugin because it adds some additional features to the pipeline. And we are going to build a Maven project later on in the video, so I'm going to go ahead and install that plugin. And to do so, I need to navigate to the Manage Jenkins page. And from Manage Jenkins, I want to select Manage Plugins. And I'm going to select the Available tab, and then I'm going to search for Pipeline Maven. And this pulls up the Pipeline Maven Integration plugin. So I'm going to go ahead and select that, and I'm going to select Download Now and Install After Restart. And I selected the restart after it's been restart automatically after it's been installed. So Jenkins is restarting, and once it's restarted, we'll be able to utilize that plugin. So now that that plugin has been installed, let's navigate back to the dashboard, and we're going to create our first pipeline job. So to create a pipeline job, I'm going to select New Item, and I'm just going to call it Test Pipeline Job. And then I'll select the pipeline item here, and I'm going to select OK. Now from here, I'm going to go down to the pipeline section, and we can define a new pipeline in the pipeline section. And we have this drop down here, and the first selection is pipeline script. So we can define a pipeline script directly in this job definition, or we can define a pipeline script outside of Jenkins and version control it in an SCM tool like GitHub. We will use this option in our second example, but in the first example, I'm going to build the pipeline script directly in the job definition. Now, it's possible to write a pipeline script completely from scratch, but if you're not too familiar with Groovy or pipeline syntax, then it can be a little tedious to write a script by hand. And what's convenient about Jenkins is it gives us this tool, the pipeline syntax tool, to automatically build a pipeline script. So I'm going to go ahead and open up the pipeline syntax tool. And this tool allows us to automatically generate pipeline code. And we have two options. We have the snippet generator, and then we have the declarative directive generator. With the snippet generator, we can define individual steps. And remember that steps are individual tasks within a particular stage of a pipeline. And let's take a look at some of the steps that are available to us. So the very first step that we can do is we can archive artifacts. We can build a job that exists on this Jenkins instance. We can also echo. We can use the echo command to print a particular message to the console, and then we can enter the message here. Okay, and then when we enter the message, or we fill out whatever parameters are necessary for the step that we selected, we can select generate pipeline script, and then this automatically generates the command that we would enter into the Jenkins file. So you would use the snippet generator for automatically creating individual steps within a pipeline stage. But if you want to define the overall structure and the stages of a pipeline, we would use the declarative directive generator instead. So from here, it gives us a sample directive drop-down list. And in this drop-down list, we can select various directives. And the one that we're going to want to use is the stages directive. So we want to define multiple stages for our initial sample pipeline. Once we've selected the stages directive, I'm going to add a stage. And the first stage that I'm going to define is the build stage. Okay, so this stage is going to be responsible for building the code base, whether it be, a C++ code base or a Java code base. And the build stage is going to contain steps. So the build stage could contain parallel stages, so we could run other stages in parallel of the build stage, sequential stages, or a matrix. But in this case, for a simple pipeline, we're just going to have steps included in this stage. And then after specifying that steps are contained within this stage, I can also specify additional options. So for instance, I can specify that this stage should run on a particular subset of agents, maybe Linux Jenkins agents or Windows Jenkins agents. And then I can also add when conditions to the stage. I can add post stage or build conditions. I can add environment variables for this particular stage. So there's a lot of options that I can utilize in a stage. But I'm going to leave it as that and create a new stage. And we'll call this the test stage. And this will also contain steps. And then we'll create one last stage. And we're going to call it the deploy stage. Okay. So the testing stage, of course, would be the stage where you would test the code that was built in the prior stage. And then in the deploy stage, ideally, if the test passed, this would likely be a conditional stage. If the test passed in the testing stage, then you would deploy your changes to production, or maybe if you had like a QA environment or some sort of promotion process, you would initiate that promotion process. So these three stages represent the skeleton of a new pipeline. And to generate the code for these stages, I'm going to select Generate Declarative Directive. And you can see here that it automatically generates the stages. Okay. So we have the build stage, the test stage, the deploy stage, and then within each stage, we can have one or more steps. So what I'm going to do is copy this generated code into my editor, and I'm going to begin a new Jenkins file. So I'm going to open up VS Code, and before I paste this code in, I need to define a pipeline block. So I'm going to say pipeline and then brackets, and directly under the pipeline block, I'm going to specify agent any. And what this statement means is that this pipeline can run on any available Jenkins agent. And then after the agent any statement, I'm going to paste in the stages block as well. Okay, so now we have our stages defined within the pipeline block. But right now this pipeline doesn't have any steps defined within the stages, so let's define a step within each of the stages. So I'm going to use the snippet generator in Jenkins, and let's use an echo statement. So I'm going to click echo here, and then let's just say hello world, generate pipeline script, and then let's copy this into our new pipeline script. All right, so I'm going to delete this comment here. I'll paste in the echo statement, and here we'll say building, and then for testing, as you can imagine, we'll say that we're testing, and then same for here, we'll just say that we're deploying. And then we'll add one more to indicate that the pipeline is completed. Okay, so this should be a valid pipeline, so let's go ahead and copy it and navigate back to our pipeline job definition. And I'm going to select configure and go back to the configuration page. And then under the pipeline section, I'm going to paste the pipeline script into the field here. Okay, so let's go ahead and click apply, click save, and I'm going to go ahead and build the pipeline. And it looks like the build failed, so let's go ahead and open up the console output, and I can see here that it looks like it was expecting a closing bracket at line 23. So let's navigate back to the editor, and okay, it looks like I missed the closing bracket for the pipeline. Okay, so let's move that in one. Alrighty, and then let's go ahead and copy this updated script, and then we're going to configure again, and then we'll paste it back in. All right, let's go ahead and save, and I'm going to build again. Okay, and now the build is passing, and in addition to a passing build, you'll notice that this stage view also popped up after the build completed. And the stage view basically gives us an overview of what happened in any particular pipeline build, and it separates it out by stage. So we can see here the status of the build stage, the status of the test stage, and the deploy stage. We also can see the average stage times, which in this case there's only one run, so it's the same as the actual the current execution of this build. So it didn't take long, 391 milliseconds. These are pretty quick stages. And for each stage, we can see logs contained within that stage. And you can see our echo statement building in the build stage, and same for the test and deploy stages as well. So you can access the logs through this interface, but you can also, of course, open up the console output and see roughly the same, but maybe a little bit more verbose. So as you can see, writing a basic Jenkins pipeline script is pretty straightforward, but of course you want to build, test, and release code in a pipeline script. And in this example, we didn't have any code that we built, tested, or released. So let's go ahead and create a new pipeline, and we'll actually build a Maven project in our new pipeline, and we'll also utilize the pipeline Maven integration plugin. And before we create the new pipeline job, I want to real quickly show you the GitHub repository that we're going to build. And it's this one, the sample Maven project. And it's a very basic Java application that just prints hello world to the console. And it has a single test class using JUnit. And in the single test within that test class, it just runs an assert true on a condition true. So the test should pass. And this is the same project that I used in earlier videos when we were discussing Maven jobs in Jenkins. So what we're going to do in this repository is create a new file, and it's going to be a Jenkins file that contains our pipeline code, and we'll keep it at the root directory of the project. So I'm going to select add file, create new file, and then we're going to call it Jenkins file with no extension, just plain like that. And then we will define the pipeline block here. And agent any statement. Okay. And then we're going to generate, automatically generate the rest of the pipeline. So let's navigate back to Jenkins and we'll create a new pipeline job. So I'm going to navigate to the dashboard. And from here, we'll select new item and we'll call it test Maven pipeline. And then I'll select pipeline and then select OK. And from here, we'll scroll down to the pipeline section. And for the pipeline definition, instead of defining the pipeline script directly in this field, we'll pull the pipeline script from SCM. So I'm going to select pipeline script from SCM. And then for the SCM system, we'll select Git. And then we're going to specify this repository's URL. So I'm going to select open a new tab. And I'll copy the SSH URL of this repository. And we'll paste that in. And it gives me an error code since I haven't selected credentials. So I'm going to go ahead and select an SSH key pair that I previously created. Okay, so it looks like it authenticated correctly. And then under branches to build, I only have the main branch, so I'm going to update the branch specifier. And then under script path, we have to specify where the Jenkins file is located in the repository, since we're keeping it along with the code base. And in our case, we have the Jenkins file at the root directory of the repository. So we can leave this as is, but if we had the Jenkins file in a subdirectory, we would have to specify that path in this field. And now we're going to define the actual pipeline, and I'm going to use the pipeline syntax tool. And I'm going to select a declarative directive generator, and I'll select stages. So I get a stages block, and then I'm going to add a new stage, and we'll call it Maven install. Since within this stage, we're going to invoke Maven and we're going to run the Maven install command on our Maven project. So this stage will contain steps, and this is going to be the only stage that we really need, since Maven install is going to, complete the full life cycle. So I'm going to select generate declarative directive, and then we get our stages block. I'm going to go ahead and copy this text. I'm going to navigate back to our Jenkins file in GitHub, and we will paste the stages block within. And let's navigate back to Jenkins. And I'm going to scroll up to the snippet generator, and we'll define a new step. And this is where the Pipeline Maven plugin comes in. So I can utilize a step called with Maven, okay? And then with Maven provides a lot of options. So with a specific Maven environment, I can perform Maven operations. So I can specify a particular installation of Maven or of the JDK. I can specify Maven settings as well. So there's a lot of options that the Pipeline Maven plugin provides. For this use case, I'm going to use essentially all of the default selections. And I'm going to scroll down to generate pipeline script, and generates a very simple with Maven block. And I'll go ahead and copy that. And then I'll navigate back to the Jenkins file. I'm going to paste that into the steps section. Okay. And in the with Maven block, I'm going to invoke the sh utility, and then I'm going to invoke Maven. So I'll say Maven clean install. All right. And that should run Maven, perform a clean, and then perform the install lifecycle. And this should be all we need, since the Jenkins file is stored with the code base itself. If the Jenkins file was stored in a different code base than the Maven project, then as an additional step, we would also have to invoke Git here to clone down the code base. But in our case, since the Jenkins file is in the same repository as the code base, we can leave it as is, and this is going to run Maven clean install on our Java application. So I'm going to go ahead and commit this. And let's go ahead and navigate back to our pipeline. And I'm going to select save. And then let's select build now. Okay, and it looks like the Maven install stage failed. And I get a message here that says Maven not found. So I think that the Maven installation might not be selected. So I'm going to select configure, and let's open up the pipeline syntax. I'll select with Maven again. And then with the Maven installation dropdown, I'm going to take a look and see, okay, so I should have selected Maven 3. I have a Maven installation that I can specify. So I think I was supposed to select this. So let me generate the pipeline script. And as you can see, when with Maven is invoked, now the Maven installation is specified as a parameter. So I'm going to go ahead and copy this, and I'll add it to our Jenkins file. Okay. And then let's go ahead and commit those changes. Alrighty. And I'll navigate back to our pipeline. And I'm going to select build now. Okay, and it looks like the Maven install is working correctly. Okay, so just to kind of recap what I did, I specified the Maven installation that the pipeline should use when we invoked the with Maven code block. And if I take a look at Manage Jenkins and I look at the global tool configuration, under the Maven section in Maven installations, I have a Maven installation that I install automatically called Maven 3. Okay, so this is what was showing up in the drop-down menu in the snippet generator. So I'll navigate back to our pipeline, and as you can see, when the pipeline runs successfully, the Maven installation command ran, and let's take a look at the output here. So the full lifecycle, the full install lifecycle ran. So it built the sample Java application. It ran the single test, and we can see that the test ran here with 0 failures. And then we get successful artifact publishing to the local repository. And the local repository in this case is just the Jenkins workspace. So if I take a look back at the job homepage, you can see the last successful artifacts are the snapshot jar and the snapshot POM files that are contained within inside of the workspace of build 2. So these are the build artifacts of build 2. And from the build page, we can also evaluate the test results of the pipeline. In this case, there weren't any failures, and there was only a single test case that was ran, and it passed. If I take a look at the home page, we also get the JUnit, the test graph with the results of each build's tests. So as you can see, when we use the Pipeline Maven integration plugin, it makes writing a pipeline script for a Maven project a lot simpler because all we need to do is specify that with Maven block, and then we can pass in parameters to the environment, the Maven environment that is generated by the Pipeline Maven plugin. Okay, so we were able to specify an installation as a parameter to the with Maven block, and we could run other installations of Maven as well if our Maven project was dependent on an older version of older or newer version of Maven. So that's pretty much all I had for this video. I hope you enjoyed it, and in the next video we're going to continue our tutorial on Jenkins pipelines. And if you'd like to read about Jenkins pipelines, be sure to check out Lambda Test's Learning Hub for Jenkins. The Learning Hub has a lot of great resources related to Jenkins, and real quickly I'll navigate to the Learning Hub and show you. So it's lambdatest.com/learning hub/Jenkins. And you have these chapters, which are separate articles on various topics related to Jenkins. And if you are particularly interested in reading about Jenkins pipelines, you could check out the Creating Your First Jenkins Pipeline article. But again, thanks for watching, and I will see you in the next video. Hey, what's up everybody? My name is Moss, and welcome back to our tutorial series on Jenkins. In the last video, I introduced you to Jenkins pipelines, which are a key feature of Jenkins. And now we're going to take the knowledge that we've learned over the previous videos and put it to use for the next topic. In this video, I'll show you how to do cross-browser testing with the Lambda Test Jenkins plugin. Before we get started, I'd like to quickly go over the prerequisites. The first is that you'll need a Lambda Test account. Secondly, you'll need Python 3 installed on the Jenkins server. And finally, you'll also need to install the Python Selenium WebDriver module. I'd also like to give a quick overview of the Lambda Test Jenkins plugin. The Lambda Test plugin adds additional features to Jenkins jobs, such as embedding test results in the Jenkins build. You can also configure your Lambda Test credentials for your Jenkins jobs. And the tunnel also provides automatic setup of the Lambda Test tunnel binary file, which is required if you intend on testing locally hosted sites. Now that we have a high-level understanding of the Lambda Test Jenkins plugin, let's get started. Okay, so the first thing that I want to do is walk you through the code base that we're going to be testing in Jenkins. And I'm currently inside the GitHub repository, and the repo is called sample to do app. And this is basically a very simple web application, and it only has the index.html file here, and the web application is actually hosted using a feature of GitHub called GitHub Pages. So if you're not familiar with GitHub Pages, It basically allows you to use GitHub to host a web page from a GitHub repository. And to navigate to the page where this code base is hosted, I can navigate to settings in the repository. And if I scroll down to the pages section and select pages, under the GitHub pages section, you'll see your site is published at this URL. So if I go ahead and open up this URL, I should see my application, and it's the Lambda test sample application, and it's just a to-do list with a few items already filled out. But if I wanted to add additional items to the to-do list, I can just fill it out here and then select add. And I can also mark items as completed using the check boxes as well. Now, in order to test this web application, I've written a very simple Python Selenium script. And if we navigate back to the code base, we can take a look at that script. It's called test sample to do app.py. So I'm going to go ahead and open it up and we'll quickly walk through this code. And the first thing that we do after importing our modules is define the URL for our remote WebDriver. And we get the URL from an environment variable that's predefined called LT hub URL, which is short for the Lambda test hub URL. And we'll get the value of this URL in a little bit. And after we define the URL, we then define the desired capabilities using a dictionary. And the first capability dictionary key value pair here is the build name. And we actually retrieve the build name from an environment variable that is used by the Lambda test plugin, or rather it's defined by the Lambda test plugin. So this is the Lambda test build name environment variable. And also notice that we set tunnel to be true because we are going to use the Lambda test tunnel binary file. And the Lambda test tunnel opens a connection from my computer to the Lambda test platform, and it allows the Lambda test platform to connect to a locally hosted site on my computer. So after we specify the desired capabilities, we then instantiate a remote driver using the desired capabilities as well as the URL, which is the Lambda test hub URL. And after we instantiate the driver, we can then make a request to localhost. And here we're making a request to localhost on port 8081, which is where we're going to run our sample to do app when it's running inside of a Jenkins job. After we connect to localhost, the driver finds an element by name, line item 3, and it clicks that line item. So it should select the third item checkbox here. And after it selects that checkbox, we then get a reference to the text box directly below. So we'll get a reference to this field here. And then we send the keys testing in that field, and then we select the add button. So we should get something like this, right? And I'll add that to the to-do list. And then we assert that no results found is not in the page source. And directly after that, we use a very useful command here. We execute script and then lambda test status equals passed. And this will actually update the status of the test inside of the lambda test dashboard to passed. So this is a very useful script here. And then directly after that, we quit the driver. Okay, so now that we've walked through the code base and the test script, let's navigate to Jenkins, and we're going to install the Lambda test Jenkins plugin on our Jenkins instance. So I'll open up Jenkins here, and then from Jenkins, I'm going to select Manage Jenkins, and then I'm going to go to Manage Plugins. I'll select the Available tab, and then I'm going to select, I'll type in Lambda test. And the first plugin listed here, Lambda Test Automation, is the plugin that we want to install. So I'm going to go ahead and check it and then select download now and install after restart. Okay, So it's pending, and then I'll just check the box, restart Jenkins. Okay, so the plugin should be installed, and now I'm going to add my Lambda test credentials to Jenkins. So I'm going to select Manage Jenkins, and I'm going to scroll down to Manage Credentials, and I'll select the global credentials, and I'm going to select Add Credentials. And from here, the Lambda test plugin added a new kind of credential. So if I open this drop down here, you'll see Lambda test credentials. And I'll leave the scope as global. And then the username, my username is techwithmoss@gmail.com. And then the access token I can retrieve from my Lambda test profile. So if I navigate to Lambda test, and then I can very quickly access the key if I just select Configure Tunnel here. And then the key is the option here, the key option right here. So this value is the key that I would need to copy into Jenkins. So I'm going to go ahead and do that. And I'll go ahead and paste that in. And we'll call it Lambda test credentials. And then if I select verify credentials, it says successful authentication. Okay. So let's go ahead and select OK and add those credentials. Now remember that our test script references an environment variable called LT hub URL, which is the Lambda test hub URL. And this environment variable still needs to be set. So let's go ahead and set that environment variable in Jenkins. So if I navigate back to the dashboard and then manage Jenkins, and then scroll down and select configure system, I'm going to scroll down to global properties, and I have environment variables checked, and I'll select add. Okay, and we're going to call it LT hub URL, just like it how it's referenced inside of the Python script. And to get the value of the hub URL, I'm going to navigate back to Lambda test. And in my Lambda test account, I'm going to select configure tunnel. And down here where it says more details here, this is a link to documentation. And in the documentation pages, we have a link to the capability generator. Okay. If I select the capability generator, it takes me to a tool where I can automatically generate desired capabilities. This also automatically generates the hub URL that's unique to my account. And if I expand username and access keys, you'll notice down here, hub, this is my hub URL. So if I copy that to the clipboard and then navigate back to Jenkins, I'll paste that into the value field, and that's going to be my hub URL, which my Python script is referencing. And now that we've saved that variable, I'm going to select save. And we're going to create a new Jenkins job. So I'm going to select new item, and I'm going to call it Lambda test job. And it will be a freestyle project. So I'm going to select freestyle project and then select OK. And the first thing that I want to do is configure source code management. So I'm going to select Git, and then I'm going to navigate back to GitHub, and I'm going to retrieve the repo URL. So remember that it's SSH. So I'm going to copy the SSH URL, and then back in Jenkins, I'm going to paste that URL in, and I'm going to select credentials that I previously configured. Okay. And the branch specifier, I just have the main branch. Okay. And after we've set up source code management, I'm going to scroll down to the build environment, and you'll notice that we now have a new option here called Lambda tests. So I'm going to go ahead and select Lambda test. And this section is our interface with the Lambda test Jenkins plugin. If I take a look at the Selenium tests section, I can actually add Selenium test capabilities directly in this interface. So if I click add here, I can select an operating system, browser, a version, and the screen resolution as well. And then I can add as many test capabilities as I need here. The one caveat with using this interface to define the capabilities is that we have to reference an environment variable that is created by the Lambda test Jenkins plugin inside of our Python script. And to find the name of that environment variable that the plugin creates, I'm going to navigate back to the capabilities generator, and I'm going to navigate back to, I'm going to navigate back to the documentation here. And if I scroll down to the section Lambda test integrations, and then integrations with CI/CD tools, I'll select the Jenkins plugin. And in the Jenkins plugin page, if I scroll down to the environment variable for Lambda test Jenkins plugin section, it gives me a list of environment variables that the Lambda test plugin will use. One of those variables is called LT_browsers, and this is an array of combinations of desired capabilities. So you can see here, when that environment variable is printed out to the screen, it prints out the desired capabilities, and these are the capabilities that are defined within the Jenkins job here. Okay, but in order to use these capabilities, we have to reference, when we're defining the capabilities variable in the Python script, we would reference this environment variable. Now I'm not going to do that here. I'm going to use the desired capabilities as they are inside of the Python script, but it's good to know that if you do want to utilize this feature in the interface, you can utilize that environment variable in your script to do so. So I'm going to remove this capability. And the next configuration is use local tunnel. And the local tunnel or the Lambda tunnel binary file is a feature that allows you to test your private server URLs or locally hosted web apps using the Lambda test cloud servers. And since our web application will be hosted locally on this Jenkins server when we're running this job, we will need to utilize the Lambda tunnel. So I'm going to go ahead and check that box. And then in the next field, we have the tunnel name, which we can leave blank, and it will have it will be given a default name. And we won't make this a shared tunnel, and we're also not going to use the legacy Lambda test tunnel. But under optional tunnel commands, we are going to utilize one additional option when the plugin starts the Lambda test tunnel. And that additional option is --info API port, and then the port that this will run on. So what this option will do is it will provide an endpoint. The Lambda test tunnel will publish an endpoint on port 8000 that we can connect to, and we can perform operations on the tunnel. For instance, we can close the tunnel if we want to, or we can get status, the current status of the tunnel as well. We can also specify a download path for the tunnel, but I'm going to leave this blank, and then I'm going to check use workspace path to download the tunnel into. Okay, and then for the Lambda test credentials, we already created those credentials, so I'm going to select them here. And then for the last step, as a post-build action, we want the test results embedded. So from the post-build actions dropdown, you'll notice the Lambda test report. I'm going to go ahead and select that. And this action will generate a Lambda test report inside of the Jenkins build, and it uses the build name from the environment variable LT build name, which is created by the Lambda test plugin. So if you remember in the Python script, if I navigate back to the code base and I open up the Python script, where the capabilities are defined in the first key value pair, I set the build key to the value of the environment variable LT build name. Okay, so it pulls the value of the LT build name, and that's how we get the test report generated inside of the Jenkins build. So I'll navigate back to Jenkins, and we're going to add a build step, and we're going to execute shell. And we're going to add a few commands here to start a simple Python server that's basically serving the current directory, the directory of the workspace. Then we'll also shut down that server after invoking the Python script, and we'll also shut down the Lambda test tunnel using that info API port endpoint. So the first thing that I'm going to do is invoke the sleep command, and I'm going to sleep for 5 seconds. That just gives the tunnel a little bit of time to make a connection. And then after invoking sleep, I'm going to start the Python server. So I'm going to invoke Python 3 and then the module http.server. And we're going to run it on 8081 since this Jenkins server is running on 8080. And then ampersand, so that this is a non-blocking shell command. It'll just execute this process in the background. And then we'll invoke Python again, and this time we'll run our Python script. So I'm going to say test sample to do app.py. And once that script is completed, we'll be able to stop the HTTP server that's serving this particular workspace. And to do that, I'm going to use pkill. So pkill and then -f, and this is kind of like a fuzzy match for the name of the process. And we'll put in quotes HTTP server, so that should kill the Python server. After killing the server, I'll invoke sleep again and sleep for 10 seconds before shutting down the Lambda test tunnel. And to shut down the Lambda test tunnel, I can curl an endpoint, the info API port endpoint, with the delete method, and then localhost 8000, and then the endpoint is API v.1.0, and then stop. Okay, so this endpoint should shut down the Lambda test tunnel after the tests have been completed. And that should be all we need, so I'm going to go ahead and save this job. And let's go ahead and build it and see what happens. I'm going to open up the console output. Okay, and we can see that it's sleeping for 5 seconds. It invoked the server as well as the test script. And now it's killed the HTTP server and sleeping for 10 seconds. And then we curled the stop endpoint, and you can see here that status equals success. So it successfully stopped the tunnel. And if we want to check the output of the tests, we can do so by navigating to the Lambda test dashboard. And from the dashboard, if I navigate to the automation section, I can see in the very top of the list here, Jenkins Lambda Test Job started a couple minutes ago. And if I open that up, I can see that the test passed, and I can even watch the output of the test. So if I open this up and maximize it, you can see the test run pretty quickly, but you can see what the test did. So right here, it selects the third item, and then it adds testing as an additional item to the to-do list, and then we quit the driver. So it was a very quick test. And if I navigate back to Jenkins, I'll navigate to the build page. You'll notice at the bottom left section here, the Lambda test report. If I click on that, I get kind of a high-level overview of the tests, and I can navigate directly to the automation page in Lambda test by clicking these links, right? So it takes me directly to the build here as well. Okay, so that's how we can utilize the Lambda test Jenkins plugin inside of a freestyle Jenkins job. But we also want to do this from a Jenkins pipeline. So the next thing that we're going to do is create a Jenkins pipeline, and inside of that pipeline, we're going to invoke the Lambda test tunnel so that we can connect to the Lambda test platform and run the tests from a Jenkins pipeline. So I'm going to go ahead and navigate to the dashboard, and we're going to select new item, and I'm going to call it Lambda test pipeline, and I'll select pipeline type, and I'm going to select OK. And from the configuration page, I'm going to scroll down to the pipeline section, and I'm going to select pipeline script from SCM because we're going to store the Jenkins file along with the code base. And then for SCM, I'm going to select Git, and then let's copy the URL of the code base again. Okay, I'm going to paste that in and select my credentials. Okay, and then the branch is going to be main. And we'll also leave the Jenkins file in the root directory of the repository. So we'll leave the script path as it is now, and we'll go ahead and start building the pipeline. And I'm going to use the pipeline syntax tool like we did in the previous videos. Okay. And I'm going to open up the declarative directive generator, and we're going to generate some stages. Okay, so I'll scroll down here to the stages directive and select that one, and then let's go ahead and add a stage. And the first stage that I'm going to create is going to be called setup, and it will contain steps. And then the second stage is going to be called the test stage, and this will also contain steps. Those are going to be the only two stages that we create. And I'll go ahead and select generate directive, and I get the stages generated down here. I'm going to copy them to the clipboard, and then I'm going to paste them into VS Code. And before we paste the stages, I'll want to define a pipeline block, and I'll specify agent any. And then after that, we can go ahead and paste the stages block into the pipeline block. And in the setup stage, we're going to run several shell commands to download the Lambda test tunnel binary file, and then run the Lambda test tunnel so that we can make a connection and then execute our tests. So we need to get the download URL of the Lambda test tunnel, and I'm going to navigate back to Lambda test, the Lambda test documentation. And from the Lambda test documentation, I'm going to scroll down to, scroll to the testing locally hosted pages section. And if I select the first link here, how to connect Lambda test tunnel for Linux, my Jenkins server is running on Linux, so I'm going to select this link. But of course, if your Jenkins server is running on Windows, you would want to select this link. And I'm going to open up this page, and if I scroll down, I have a link here to the Lambda test tunnel binaries. So I'm going to go ahead and copy that link address, and then I'm going to open VS Code back up, and we'll invoke the shell command, and I'm going to use wget to download the Lambda test tunnel binary file. And then in the next shell command, we're going to download a utility to unzip the Lambda test tunnel binary file. So you only need to use this shell command on the first run of the pipeline, and then you can remove it for future runs. But I'm going to go ahead and apt-get install zip unzip. And once that is installed, I'm going to invoke it to unzip the Lambda test tunnel zip file. Okay. .zip. And once we unzip the tunnel binary file, we can go ahead and invoke the program. So I'll go ahead and do so. And we have to pass in as parameters the username, the Lambda test username, and we're going to use environment variables for the username and access key, just to as a best practice. So I'm going to call it LT underscore username, and then -- key for the key parameter, and we'll also reference this as an environment variable. So this is going to be LT underscore access underscore key. And then we'll also give this tunnel a name. So tunnel name is going to be Jenkins-tunnel. And finally, we'll also set the parameter info API port running on port 8000. And one last thing is we are going to run this program as a in the background. So I'm going to add ampersand and close off that shell command. Now these environment variables haven't been created yet, so we will need to create them. So I'm going to do that now, and I'll open Jenkins back up. And if I navigate to the dashboard, and I'll select Manage Jenkins. And then I'll select Configure System. And if I scroll down to Global Properties, again, we can add additional environment variables. So I'll go ahead and select Add here. And the first one will be the LT underscore username, which is techwithmoss@gmail.com. And then the second environment variable is going to be the Lambda test access key. Okay. And this value we can pull from the Lambda test dashboard. Actually, we can pull it from the hub URL. So this is in the hub URL, we pass in the username and access key in the URL. So I'm going to go ahead and copy the access key here, and I'll paste it in. And then I'm going to go ahead and select Save. And then let's open VS Code back up. And that's pretty much everything that we need for the setup stage. In the test stage, we'll essentially copy the same steps that we took in the job that we just created in the build section. So I'm going to go ahead and delete this comment here, and I'll invoke the shell command. And just like we did in the previous Jenkins job, we'll go ahead and sleep for 5 seconds just to allow the tunnel to make a connection. And then immediately after that, we'll invoke Python and we'll run the workspace. We'll serve the workspace on port 8081, and we'll do so as a background process. And after that, we'll invoke our test script. So test sample to do app.py. And once the test script completes, we'll then kill the server. So I'm going to invoke sh and then pkill http.server. Okay. Once we kill the server, we'll add a small sleep statement. Okay, we'll just sleep for 10 seconds, and then we'll curl the endpoint to stop the Lambda test tunnel. Okay, so delete, and then localhost. Port 8000, and then API v1.0 and stop. Okay. So this should work or behave essentially the same way as the Jenkins freestyle job that we previously created. Now what you'll want to do from here is copy the pipeline script, and then in GitHub, create a new Jenkins file in the root directory of the repository. Now I've already created a Jenkins file, so I'll just go ahead and open it up, and I'll select edit, and I'll go ahead and paste the pipeline script into the file. Okay, I'll go ahead and commit those changes. And then let's navigate back to the pipeline configuration page. And I'm going to click Save. And then let's see if this builds successfully. So I'm going to click Build Now. And it looks like it failed pretty quickly. So let me go ahead and open up the console output. And it looks like I was missing an end quote there. So I'm going to open up GitHub. And let's close off that end quote. Okay, and then let's go back to Jenkins and we'll build again, and let's see if we have any errors. All right, so I'm going to go ahead and open up the console output, and let's take a look at what's going on. So it downloaded the Lambda test tunnel successfully. We can see that here. And then we also install the zip unzip package, which in my case has already been installed. And then after that package has been installed, we unzip the Lambda test tunnel. And once we unzip the tunnel, we then invoke it with the parameters that we had previously, that we set previously in the pipeline. And we sleep for 5 seconds, invoke the Python server, and then we invoked the test script, but it looks like it failed here. So we should probably take a look at why it failed. So it says build name should be of type string. So let's take a look at why that didn't accept our build name. So let's take a look at the test script in the code base and see if we can troubleshoot what's going on. Okay. And it failed at line 18, but I think I know what the issue is here, because the build name in the capabilities is still using the environment variable LT build name, which, since we're using the pipeline job, that environment variable isn't defined. So if I navigate back to the pipeline script we can actually define that variable within the pipeline script. So if I edit the pipeline script and then below agent any, I'll invoke the environment block. And inside of the environment block, I'll define lt underscore build underscore name. And then we'll say it's equal to the name of the pipeline job, which is lambda test hyphen pipeline. Okay. And then we'll close off that environment block. And let's see if that fixes the issue. Okay. And I'll navigate back to Jenkins, and let's run the build again and see if we can get it passing this time. Okay. Go ahead and open it up, and let's navigate. Okay, it looks like it's running the test script successfully. Okay, so the test script ran without any errors, and we killed the HTTP server. It's sleeping for 10 seconds, and then it should close the Lambda test tunnel, which it looks like it did successfully. And let's take a look at the test results in the Lambda test dashboard as well. So I'll open up Lambda tests, and I'm inside of the automation tab. And then you can see at the top of the list here, the Lambda test hyphen pipeline, which completed. So I'll go ahead and open this up, and it says that the test pass. And if I take a look at the video as well, you can see that the test ran the same as they did in the freestyle job. So those are the two ways that you can integrate Jenkins with the Lambda test platform. You can utilize the Lambda test Jenkins plugin within a freestyle Jenkins job, but you can also run the Lambda test tunnel within a Jenkins pipeline job in the event that your release process uses a Jenkins pipeline. I hope you enjoyed this video and the other videos in this series, and thanks for watching. If you'd like to learn more, be sure to follow our blog at lambdatest.com/blog, as well as our Lambda Test community at community.lambdatest.com. You can also earn resume-worthy Lambda Test Selenium certifications at lambdatest.com/certifications.